So in the heuristics lecture, we actually left 3 example problems. So here I use a screencast to explain how to model and solve, or how to actually create a heuristics procedure to solve your problem. So we start with the knapsack problem. So in the textbook, they actually introduce a method, a heuristic method called the greedy heuristics. So we just simply use this example to explain what is greedy. So this is a problem. We have showed Excel normally took a long time to solve knapsack problem when the item size actually increases. So we have a number of items, each having a cost and a profit. So in this table, you can see we have 8 items. We know the profits for bringing this item and the costs for bringing this item. So the knapsack has budget limit C. So they can be explained as a capacity of C. So in this problem, the capacity is 85. I didn't actually list here. For the example, specific Excel example, we use a capacity of 85 units. That's basically budget that is related to cost. So find a subset of the items that does not violate the capacity and maximize the total profit of the items in the knapsack. So this is a question. So you decide how many items put into your bag, and then maximize the profit at the same time satisfy the capacity constraint. So this is the data we have plus a capacity of 85 units. So I put this problem into the Excel. So I just organize the item by the rank the items by the profits. So you can see the item 5 has the highest profit of 35, and item 1 has 32. So this is a descending list regarding the profit, and of course cost is corresponding cost for each item. And here we also calculate a ratio. So the ratio is the value profit over costs. So 35 divided by 25, you got 1.4. Similarly, you got all the ratio for each, the profit cost ratio for each item. And then you have a decision to make. Are you going to chosen this item or not? So of course, if it's 1, that means you're going to bring or choose this item. 0 means not. So this actually is a rather small problem. You can try to use Excel solver to solve this problem. So if I start the solver, my computer actually doesn't show the solver. But anyway, you can open the solver and see how to solve such a problem. And then that's not our focus today. Our focus is to talk about a greedy heuristics. So that's a first heuristic you can think about. So now assume you do not have any solution. So we start from the idea you want to be greedy on the profit. Greedy on the profit. That means you choose the most profitable items from this list until you violate the capacity constraint. So here you can see I choose the item 5, 1, 4, and 2, and it gives me a total profit of 127. And you can see the total cost for these 4 items actually is 71. Why should we stop here? So because you can think about now the budget used is 71. If you plus 1 more item 3, then plus 17. So the current value is 71. If you plus 17, Now you can see you will get 88. So which actually is a larger than your capacity, your given capacity. So you cannot actually bring the item 3. This is a greedy heuristics. So until you violate your capacity constraints, then you terminate or you stop. Even though you may argue, okay, I can bring item 8. So wait, we think about that later. So for greedy on cost, that's also one idea. So you can actually pick up the cheapest item to bring. So in this case, I click it. You can see actually I brought the item. I choose the item 1, 4, 3, 8, 7, 6. If you check the cost, they are actually the cheapest items you could choose. So that's how I actually got this result. And we stop at this time because if you continue to add the next cheapest item, there's actually something wrong here. Then actually they will violate your capacity constraints. So why I bring the D2? 79 it should be. There's something wrong here. I stop. So I click the wrong cell. So this actually is the cheapest items you should bring. And then you can see the capacity up to 72. If you bring next the cheapest one, it will violate your capacity constraint. So you stop here. Similarly for greedy on ratio, so 69, you can see that's because we actually choose the most effective items. For item 1, we give you a ratio 4. So the item 4 gives the ratio 21. So you just choose this most effective or profit cost effective items. And then you stop when you reach the budget of 69. So that's actually the simplest idea about heuristics. Be greedy and find the feasible solution. Obviously, this solution looks not that good. So you can think about extended greedy. So we call it EG. So based on the greedy on the profit, we can further search to improve. For example, for the greedy on profit, if you continue to search on the item list, if you add item 8 into the bag, actually you can see you're still not violate the capacity constraints, but to add you more profit. So that's one extension. Another is the extension based on the cost, greedy cost method. So again, so you can continue to add items or to choose the next item, not violate the capacity constraints, but still increase the profit. So not strictly greedy on the cost. You also integrate with the capacity constraint. In this case, actually take the item 3 out and add item 2 in, because item 2 is more profitable in the item 3. Even I use more budget, but also give me higher profit return. For the extended greedy on ratio, that's the same. Previously stop when your budget reaches 69. Obviously, you still have about 16 budget to use. So in this case, so you can actually add more into your bag, and then at the same time add the more profit. In this case, you probably not strictly greedy on the ratio. You also combine with the capacity availability. So about extension, it's totally up to different problems and different ideas. So here, the purpose is to improve the solution. So I couldn't show you how to solve the problem in the solver. I don't know why I cannot open solver quickly. Oh, something happened, something wrong in my Excel. But you have the Excel book, workbook, so you can open the Excel solver and see how to solve such a problem. So I actually have the optimal solution here, which is total profit 150 and the budget up to 84. So that's a knapsack heuristics. So the idea is just to show you what is heuristics. Heuristics basically is an idea to start with and to find a feasible solution. Of course, heuristic solutions are not optimal normally. So we continue with the screencast. Next problem I would like to see is a traveling salesman problem. So this problem, we can see this problem from our lecture slides. So just recall. So now, given n cities and a distance cost matrix in CIG here in this table, so find a tour that visit all the cities exactly once at a minimum driving distance and all costs. So now you can see you have 6 cities to visit. So here you want to sell the products and you need to visit all the 6 cities, but you don't want to repeatedly visit the same city. So make sure you just visit the city once. And then would like to minimize the total driving distance. That's also the minimize the cost. In this problem, we introduce a nearest neighbor construction heuristics. So the idea actually is the same with a job sequencing problem in the textbook. So the greedy heuristics is that to search. You decided to start from one city and then search which city is closest, and then you visit the closest next city. And you always search the closest city around the current city. So that's a neighborhood searching. So let's see the Excel workbook about this model and the solution. So first, it's possible to solve such a problem to in the Excel solver, because it's basically as an integer programming model. So now you can see we have the mathematical model in this Excel workbook, and also we have the decision variables listed here. So again, the focus of this problem is not the LP solver. So that's why we just present this mathematical model here. But the focus is in how to find the heuristic solution. So from this model, you can see actually the model is rather complicated, and also the logic is not that easy to explain. So just for your reference. That's also why. So when the problem is difficult, so we pursue a heuristic method. So here you can see I have greedy heuristics start with. So I do the heuristic first manually. So I show all the steps I go through, then until I find a satisfied or good solution or good routes. So first I start to think about start from job 1. So that's also from the textbook. You have actually a start point. In this one, so I just start from the job 1, and then based on the greedy heuristic in the job sequencing method. So first I choose the cheapest job to do, or the closest city to visit. So which is actually, so I visit from the city 1, I visit city 4. So I drive to city 4. So then I give a number 1. So this actually basically is my decision, which city I'm going to visit first. So I'm visit the city 4, and then you check on this list. Now you're in the city 4, or you're in the job 4. So it's kind of a similar idea, job sequencing, or the traveling salesman problem. So in the city 4, then you choose the closest city to visit. So in this case, the city 2 actually is closest, so number 11, the cost is 11. So I choose the job 2, or the city 2 to visit. And then next step, we come to city 2. You always stand at the current city and to look the next city to visit. So in the next city, you can see the city 3 is the closest, so which is 11, costs 11. So this number is the smallest on the row. So then I put 1 in the city 3, so all x to 3. And that's how I choose my routes. So now come back to the initial parameter matrix. Now you stand in the city 3, and then you choose the closest city to visit. So now you have the number 12, number 10. So number 10 is the smallest, but you can see the number 4 is already being visited. So you should not choose from city 3 to city 4. Then you see the next cheapest one is city 2. And city 2 is also visited before. So you should not choose city 2 either. So the next cheapest one is city 6. So that's why I choose city 6 to visit. And continue with this process. Now you stand in the city 6, and then the cheapest available city to visit actually is city 5. So you just put the 1 in the X65 cell. So here become 1. So that's how you go through this process. Now you can review your routes. So if this is a loop, then you start from city 1 or job 1, and then you go to city 2, and then go to city 2, and then go to city 3, and then go to city 6, and then go to city 5, and then go to city 1. And then you calculate the total. You calculate the total cost. So now it's 126. And at the same time, you calculate the total job from each city, or start from each job. So for example, from city 1, so you do the total jobs to the different cities should be only 1. So here you have all these total jobs equals to 1, start from each city. And also from each city to visit, the destination city is the same. You should have only 1 inflow or flow in value. So should also be 1. So then you can check if your route is correctly constructed. If something wrong, this value can be 0 or not 1, then that's something wrong. So now currently this route looks good. So we're done. So you got the first heuristic solution. And also you can further extend this greedy heuristics by a little bit transformation for your initial parameter. This is also based on the textbook idea. So if you choose the minimum values on each column in your parameter or the cost matrix, then you transform the cost matrix transformed into a new matrix. So here it's called transformed data. And based on this transformed data, you can also actually go through neighborhood search. So you start from, for example, city 1. All these examples I gave is start from city 1, and then you can choose the cheapest city to go around. However, because I actually designed this problem with circular route, so you can see all this route also starts from the same idea. So if you ignore so if I got a route here, 1, 6, 2, 3, 4, 5, 1, and you can actually see this route is a circular route. So city 1 is the start and the end point. So if you do the same, you start from city 6, then you actually end in the city 6 as well. So this method will not limit you have a fixed start or not fixed start. You can decide which city you start with, so it doesn't matter. So this is the heuristics method or job sequencing heuristics introduced in the textbook. So just try here, just give a very quick brief. So this is the same problem actually. You can use a different method to solve that. You use the same method, the same idea of job sequencing heuristics. But if you do the manual searching, you can see that's actually quite trivial. Now you have only 6 cities to visit. If you have like 60 cities, there are a large number of cities. How could you actually many jobs? How could we actually do that manually? So that's possible. You can actually write this procedure, heuristics process into programming code. So I actually already mentioned in the lecture video. So the VBA programming is not required in the exam, but we do show you how to actually do the macro-based heuristics, because Excel solver cannot help you and do everything manually is rather inefficient. We need actual assistance. So in this problem, I actually provided you with a macro. So this actually is the initial information we have. So, and then we have the, I have a button set for you. So for example, in this example, you can choose to click the button nearest neighborhood or nearest neighbor. That actually means you run the heuristic algorithm. So it requires you to put the initial parameters in. So in this problem, enter number of nodes. So I have 6 nodes. So I enter a 6 based on the parameter you have. And then they ask you to enter the starting point. So I would like to start from node 1. Okay. And now you can see actually already got the solution. I probably should already delete it before. So let me try again. So nearest neighborhood search 6, start from 1. Okay. Yeah, now you can see actually I got the root with 1 as a starting point. And then you have these values here. There's something wrong here probably. I should just change them into 3, 4, 5, 6. So here you can, it should be the correct setting. So you can actually use this macro to try what to do. Of course, in this problem, the numbers, the input should always based on the parameter you have here. Otherwise, it will not work. And I can also show you what's going on. So here you actually develop the VBA code in Excel by click the developer tab on the menu bar, and then you choose Visual Basic. And now for current projects, then you can actually choose to build a module. So for this problem, we put the module here. So in this module, have some VBA codes written. So what's happened in the Excel worksheet with this button actually is just run this code. It's definitely not necessary for you to learn how to write this code, but if you're interested or if you want to learn about that, it actually will be very useful in the long run. So I close it. This is a TSP problem with macro. So I have the optimal solution here. Let me see if I can open server. Oh, something wrong with my Excel, so I cannot open server. But in your Excel workbook, you should be able to open the server with the Excel server to solve this optimal problem. I do not explain what's going on here. As I said, this is not our focus. It's just for providing you a benchmark for your heuristic solution. So our heuristics provide a 126 tour length or the cost, and the optimal solution is 115, so it's not too bad. So it's quite okay. Here we also get 126. So this code actually is also the nearest neighborhood search. So it's not based on transformed data. So that's why we did not get even better solutions. So that's about this traveling salesman problem.